Okay, now I called this a pendulum. I would also call this in short, there's a whole bunch of things that have exactly the same kind of behavior. Here is our fixed coordinate system, big O, big Y, big Z. And this is a conventional pendulum. All right, and so it's of length L, and we could call this, if you want, even though this is O, it's also, you could also call this A, and this is theta. And this whole thing, we're going to say this whole thing is rotating with an angular velocity and an angular acceleration. Okay. Everybody with me? This is what I want to do. It's a simple matter. The whole thing's moving. We simply want to find the linear velocity and the linear acceleration of that point. Anybody got a suggestion as to which of the formulas on the board we ought to use? How about, is that Max, sir? It is him, yeah. Max sitting there going, his buddy next to him, that's him. Anyway, sorry to wake you up. I was simply, let's go for velocity here. Which of the formulas up here shall we?
V sub A is 0 since A isn't moving. Then the linear part is omega cross.
Whoa, okay, yeah, hang on a second. I tell you what, you keep talking and they'll get you on audio while I write. Okay, go ahead.
All right, so use V sub B. V sub A is going to equal 0 since A isn't moving. V sub B, or omega cross RAB is going to be the velocity component, and then be relative to 0 since B isn't moving further away from A.
Okay, let me try to capture what Max said. I thought I heard you say V sub A was 0. Correct? Your buddy. What's your name?
Nathan?
Nathan. Yeah, how was he able to get away with that? He's not moving, all right? This is fixed to the ground. Fixed pivot, perfect. Okay, and then Max said omega cross R, fair enough, safe bet, okay? And then I believe he said this. Nathan, how'd he get away with that?
Relative to the frame, it's also not.
Exactly. Now we haven't, in point of fact, we haven't done the frame yet, but let's do that now. Let's do that right now. So what, kind of getting ahead of ourselves here. Here's how you would work this. Here you'd say, this is big O, this is big A, this is big Y, and this is also little x and so forth. Oh, excuse me, it's absolutely not. All right, get carried away here. Okay, this is the situation. This is kind of what we're doing conceptually, is that we're saying, okay, I get to choose what point A is for the origin of the body coordinate system, the coordinate system that goes with the body. I'm going to, big surprise, I'm going to choose the origin to be the one that's fixed. But this is a surprise. It's a little bit of a surprise. I'm going to choose a different coordinate system. Instead of our conventional or familiar big I and big J hat, I'm going to choose another one, just like this. And they are, of course, perpendicular. And as you'll see in just a minute, it's because it makes the arithmetic easier. Okay, it's convenient. We could do it. You could say, well, I want to do it this way. I want to do it with big I and big J. You can. You can get the right answer. It's just that it's going to be easier doing it this way. Watch as Max continues. Max, if this is the choice, or excuse me, if this is the choice of the body coordinate system, do that for me. What's R sub AB?
0.
Once again,
0.
good guess. No cigar. Nathan? What's R sub AB? What is R sub AB? What are we talking about here? R is the vector from A to B. Indeed? Yeah, Max?
It's just I hat.
That's it? Not exactly. Say again?
X.
X, keep going. There's more letters on the board. This guy back here in the pink. What's your
Noah.
Noah? Is it Noah or Noam?
Noah.
Second word, Noam. And you said,
R, big R times I hat.
ooh, very close. The guy in black in the back. Excuse me, what's your name?
Danny.
Danny.
L, I hat.
Excellent, excellent. Danny wins the, rings the bell. That's it. Anybody, you guys know, does the name Groucho Marx mean anything to you guys? Really? The people that know, I'm reluctant to bring this up because once upon a time, who is Groucho Marx? Robin, is that you? Yeah, right. Who's Groucho Marx?
He's one of the 4 Marx brothers.
One of the Marx brothers, for sure. Among other things, a comedian, four brothers, go way back to silent film days, if I recall correctly. But they had not only they have a radio show, but they also had a TV show in the very early days of TV. I'm dating myself here in the back row going, but there was a show, and the premise of it was Groucho would interview a couple out of the audience, and anytime either one of the members of the couple would say the magic word, a pre-chosen word, a duck would come down with prize money. Anyway, take it as a cultural lesson. Anyway, Noam made the duck come down. This is exactly the right answer. This is the right answer. R sub AB is very easily described with this choice of coordinate system. Again, body coordinate system. So I'm going to let you guys off the hook here and simply do it. Okay, that's it. That is, these guys already blew up the two terms on either end. All there is omega cross R. Omega is omega times K, K hat rather, and R is L I hat, and sure enough, K cross I is J, all righty? So you got omega L I. How about it? Danny, you're on a roll here. Where would I draw that? If I had to draw this, where would it be? If I wanted to draw this. Yeah, Danny's going. I think he's telling me the answer. He's either telling me to leave, perhaps. But anyway, no, Danny's got it absolutely right. So there is omega sub L times I. It's in, or excuse me, J. It's in the J direction, and the magnitude is omega L. Clear enough? And again, you can do this in a flash because you made the artful choice of coordinate system. Okay, so we're rolling now. Okay, so Danny, how do you feel about acceleration? All right, watch. I'll write the equation, and you tell me what I can get rid of. Okay, so I'm going to say that the acceleration of point A is A sub A plus alpha cross R sub AB, because it always is, minus A squared RAB Okay. All right, I believe I copied that correctly. Again, I did nothing but copy this off the board. I just simply copied it forward. Okay, Danny, whittle it down for us.
We could get rid of acceleration at both ends, AA and A1.
Okay, Danny says this is 0 and this is 0. Could you justify that, please? How did you justify throwing away the one on the left?
Well, point A is fixed, so it can't possibly happen.
Absolutely. Danny says point A is fixed, so it can't have any, the coordinate system, the body coordinate system itself's origin is not moving. How'd you get rid of this one?
Relative to the frame, point B is fixed as well. So,
Say again?
relative to the intermediate frame, point B is fixed as well.
Precisely. Point B, the point B of which we speak here, is fixed in the body. Okay? Not like that diagram there, but it's fixed in the body. So not only does A rel disappear, but V rel disappears as well. I'm still listening? Are we done? Danny's a little hesitation there. Okay, Isabella? Ooh, very good, very good. Isabella spots another economy. If V-rel is 0, then so is this term. No Coriolis if the bug is not moving on the Frisbee. Fair enough. So we are left with these two terms, and if I may, in the interest of time, this is what alpha is. This is this term. Okay. And that's that term. So, just rearranging a little bit. All right, now I'm going to draw a different diagram than this one because now I'm speaking of acceleration, not velocity. This is big X and big Y, about which we don't care. This is the pendulum of length L, and down here, how many components of acceleration are there? 2, 3? 2. 2, exactly. There is this one. And Isabella. Is it Isabel or Isabella? Ah, you brought it up. Why is it pointing in this direction? And what kind of acceleration is this? Exactly. This is the centripetal. You know, when you're spinning something around your head or you're on the merry-go-round and it presses you against you, this is the centripetal acceleration. All righty. And the other, I copied that correctly, alpha Lj. And what's that one? Eulerian, exactly. That is the Eulerian acceleration. That comes from the fact that this guy is itself accelerating. All right? You get this one if it's simply spinning. If there's angular velocity, you're going to get centripetal acceleration, okay? But if you have angular acceleration as well, you get this term to boot. So, okay, so this is our A sub B. Got two components. Fair enough? Question, comments? Complaints? Yes, ma'am. Your name, please. Sally.
Although it's not relevant to this problem, can you describe kind of the physical meaning of the Coriolis acceleration?
Excellent. What was your name again? Sally? Yeah, Sally has asked the $64 question, which is, what is Coriolis really? I mean, that's how I interpret that. And let me say, I plan to give you a more extensive answer to this, but this is a perfect opportunity because it's break time anyway. Let me show you a little movie, all right? And I have to tell you, there's probably more movies about Coriolis on the internet than anything this side of kittens, all right? So you should not be bashful about, and many of them are very good. This one is mercifully short, so here we go. The question on the floor is, what on earth is Coriolis? No pun intended. All right, I got to find it here. Now listen up. This has sound, so if you're good, Dave, give us some sound. And it's all of 20 seconds long, so do listen up.
To an observer above the merry-go-round, the path of the ball appears straight, while to someone sitting on it, the ball appears to curve to the left. This exemplifies the Coriolis force, whereby to an observer on the rotating Earth, the path of an object appears to be deflected, and this is a result of the Earth's rotation.
Yeah, all right. Now, the only thing I quibble about, I mean, this was all, I don't know, Kim, you probably have your own view of this, but the only thing I kind of quibble with is his use of the word force, all right? A lot of people use this word loosely, all right? As far as I'm concerned, Coriolis is an acceleration. Coriolis is simply a component. In fact, it's just that, a component in a symbolic expression for acceleration of a point, acceleration of a point that happens to be in a rotating frame like the Earth. All right, now this is the spooky part, because for most things we do on a daily basis, human scale, nothing's moving. The Earth is, it looks like an inertial reference frame. You stand here and you say, well, is anything moving? Well, no, all right? But in point of fact, the Earth is moving, as are you. It's just that it's so big and you can't see it. So let me, here you go. I love the British accent on it. Anybody here British, or anybody speak British? Sorry about that, I just had to do that. All right, listen up.
Their direction is influenced by many factors, including the rotation of the Earth, the size and shapes of the continents, the prevailing winds, and even water density. Ocean currents caused by prevailing winds are called drift currents. In the northern hemisphere, the circulation of the oceans is clockwise, and in the southern hemisphere, the currents are anti-clockwise.
Ooh. Isn't that spooky? Did you get that last part? Or did you hear the last part? It basically said, you know, the currents are caused by a lot of things, but those that are caused by wind, okay, the currents that are caused by wind are clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. So if you will, just chew on that until next time, and we'll go over this in some detail. But that's an excellent question, Sally.